Hello and welcome back to part 3 of writing FreeDOS programs in C. So in part 2 we learned about the general structure of a C program, and we learned about variables, and we wrote a couple of small simple programs just to get started. But if you want your programs to do more complex behavior, you're going to need to understand how to do flow control, how to branch off to do different things in your program depending on certain conditions that are being met. And so that's what this video is going to be about, learning about flow control. So let's get started. Now, the first thing you need to know about flow control is how to do a test. So let's actually start up a program here. We'll just call it test.c. And if you remember the structure of a program, we need our include standard IO. We need to define our main function. And the function itself will go between the curly braces. Let me just start up with two variables here. We'll call int. We'll have a variable called I. We'll give it a value of 1, and another one, integer of a, and we'll give that a value of 2. So there's a couple of different ways that you can do tests. That's the core of doing flow control. You need to be able to do certain kinds of tests. So what are the different tests that you can do? Well, the basic ones are you need to be able to test if two values are equal to each other. Also need to look at if one value is greater than another, or if one value is less than another. But there's similar kinds of tests you can do that are related to that. You can do another one that's not equal to. You can also look at if one value is greater than or equal to another value, or, as you might guess, less than or equal to. And so how do you do those tests? Well, to compare two values to see if they're equal, you're going to use two equal signs. This is very similar up here when we did the initialization of the variables. We defined an integer variable called I, and we assigned a value to it, 1, by using a single equal sign. And that's how you assign a variable value, is using a single equal sign. To test if something is the same, you're going to use two equal signs. And that's an important thing. Never mix those up. How do you test if something is not equal to? Well, you're going to use exclamation point equal. And you're going to see this exclamation point in a couple of other places, and that's basically a not. That's saying not equal to. So these two symbols together without a space in between indicates one value, or would test if one value is not equal to another. How do you test if one value is greater than another? Well, you use the greater than symbol. Same down here on the less than, which use the less than symbol. If something is greater than or equal, you're going to use greater than followed by an equal sign, no space in between. And then you might guess that less than or equal to is less than, and then an equal sign, no space in between. And so these are the different comparators that we can use in making these tests. So what's it look like when we do these tests? Well, the first test, the most basic test that you can make is an if statement, right? So you're going to test if something is true, and if it is, you're going to do something. And so we might have a statement that says, if, and then inside these parentheses, we're going to put in our test. So what test might we do? Well, we might say, is I equal to 1? And if it is, then it's going to print out a statement. We'll just do a putS statement. It says, I is equal to 1, right? That's what we're going to print out. So you can do this as a single line statement. Most of the time, though, you're probably going to be putting multiple statements behind that if. And when you need to do that, you're going to use you're going to use the curly braces to try and block together multiple statements. So you would write that same statement this way: if I is equal to 1, and then we're going to use a curly brace, and then over here another closed curly brace, just the same way that our main function has all the statements enclosed by an open and closed curly brace. Our if statement, our if block, is closed by these open and closed curly braces. And so you would say put s, I is equal to 1, and then you might have other statements here, right? Whatever those might be. Now, I've done a test here for what if I is equal to 1. At the same time, I might want to do a test that says, okay, if I is not equal to 1, so if I is equal to 1, certainly do these things, but if I is not equal to 1, do something else. And so the way that you would do that, if you have any familiarity with other kinds of programming languages, you're going to use an else statement. And again, you can put this on one line, but most of the time you can be doing this inside some sort of a block. And so here we would just say put s, I is some other value. And then we'd have other statements that we could put in here. And so this now does two different things kind of in one statement. So we're testing with an if, and the condition we're looking for is I equal to 1? That's a question because we've got the two equal signs, right? We're not assigning, we're testing to see if I is equal to 1. And if it is, then we're going to do all the things that are inside these curly braces. And in this case, I only have one statement. It's going to print out the put s statement. At the same time, if I is not equal to 1, it's going to do this. It's going to do the else. It's going to do all the stuff inside these curly braces, and in this case, it's just going to print out the message if I is some other value. Now, yes, I could actually do this as a separate statement if I wanted to. I could actually say if I is not equal to 1. I could certainly do that. And in some cases it is useful to do two different tests like that, but usually it's when you're trying to test some other condition that is unrelated to the one up above. If they're actually related, if I is 1, do something. If I is any other value, do something else. You're typically going to do an if-else type of statement. Now, what if we want to test other things, right? So I might be equal to 1. That's one test that we want to do. But what if I is equal to 2, or I is equal to 3, or I is equal to some other value? How do we do that? Well, there's really only the if and the else. But you can actually put them inside these blocks. And then I'll clean it up in a little bit. So if you know see it all, you'll see me clean this up in a little bit. So we could do inside the else, we could do another if statement. If I is equal to 2, then do this. And that would be, we might put out the statement, put s, I is equal to 2. And we'd have some other statements here. And we'd have an else statement where we do something else. And so what else we want to do? We also want to test for if I equal 1, is I equal 2, or is I equal 3? And we would put that in here as well, right? So inside that else, we would say if I is 3, do this. And in that case, we're going to print out the message I is equal to 3. Yes, this is the last block I'm doing. Else, we're going to say just put s, I is some other value. And so this is a block that you can do, just to highlight it here. We're going to test if I is equal to 1. If it is, it's going to do these statements. And then else. And so, all right, if I is equal to 2, then it's going to do these statements because it's inside, I is not equal to 1 in that case, right? So we're doing the else, so now we're looking at if I equals 2, then it's going to do these statements. And if it's not 2, it's okay, well, then what else can it be? Well, otherwise, it's going to be if I equals 3, then do this statement. And if it's not any of those statements, I've got one final else here, and that'll catch it and say, put s, the I is some other value. So yeah, you can nest these like this. Now that's a little bit messy, and you really won't find programmers doing this kind of nesting. They'll actually do a little bit of cleanup. So remember up here, if can be a one-line statement. Well, so can the else. It can be a one-line statement. And an if-else together counts as one statement. So what you can do, and what actually a lot of programmers do, is they'll just do this. Else if, then else if I equals 2, then do this. And now I need to clean up my braces because I've gotten rid of this one. Okay. And then I've got another else in here, and I don't need, I'm going to combine that. Else if I equals 3, and now I need to get rid of that block. And then a final else. And you can see all we're really doing is continuing that nesting. I mean, the compiler is not going to see it any differently if you use the braces or not, but this is becoming easier for us to read. And in fact, it becomes really easy for us to read if we nest everything at sort of the same level, or indent everything at the same level. So you can see this starting to come together. This is me unindenting everything the manual way. And you can see that all we've really done is we just changed the indenting, but the instructions are the same. You still have an if, followed immediately by an else. And all we're really doing is at the compiler level, is we're tacking in another if statement as the else. And in fact, that if statement has its own else, and the arguments to that else has another, the statement being executed for that else is another if-else block. So the way that you read this is more like the way a human would read it, right? So if I is 1, then do some stuff. Otherwise, else if I is 2, then do some stuff. Else if I is 3, then do some stuff. And then for any other value, do this stuff at the end. And so that's how you would do an if and an if-else, and how you would stack these multiple ways of doing if-else. Now, if we're trying to combine a couple of things, right? So here I've done, well, let's follow this for a second. There's another way that you can do this kind of test on a single variable, right? Here I've been looking at if I is 1, or if I is 2, or if I is 3, or for any other value of I, right? So we could actually do that another way if we're just looking at one variable. And that is with a flow control called switch. So with switch, we want to be able to go off of one particular variable. And so we need to give that in parentheses. And so what's the variable I'm looking at? I want to look at I. Now this has different usage. So you'll see that the syntax is a little bit different. So again, but though we need to have the curly braces. And we want to test for different conditions of I, different values of I. And the way that you do that is there's a keyword called case, right? So in case the value of I is 1, then colon, we're going to do some commands, right? So what commands are we going to do? Well, let's do it up we have above, put s, and then we're going to say I is equal to 1. And just so that when we run this later, we know that this is part of the case statement. We also have case 2. Now, if you know C programming, you know that I just skipped a step. I will come back to that in a second. Case 2, if I is equal to 2, then what's it going to do? It's going to do a put s I is equal to 2, and that, so we can see it when we run this later, is from the case statement. Or I could be 3. So case 3, colon, we're going to put the string I is equal to 3. And again, so we can see this later, we're going to just mention this case statement. And then for any other value, what do? Different keyword in this case. In this case, it's default, colon, and then we're going to say put s. What do we have up above? We said, oops, we had up above, we said I is some other value. Oops, and let's actually mention this is from the case statement, or actually in this case, it's the default statement. And then down here, I have the closing curly brace, which matches the one up here. Now, we also, at the end of every case statement, we also need to add one other thing. And that is you need to stop the flow inside this switch statement. You need to specifically break out of the switch statement. Otherwise, what will happen is if I equals 1, then it's going to start here. And it would print out I is equal to 1. It will also print out I is equal to 2. It will also print out I is equal to 3. It will also print out I is some other value. Why? Because these are basically, you can think of it as entry points. So to stop processing on a case statement, we actually need to add the word break. And that will break out of the switch statement. So I'm going to put that in here behind every one of these. Break. Break. Now the break at the end, since this is actually the end. There's the closing curly brace for the one that was up here. We don't need to have a break statement. Why? Because it's already reached the end. So in this case, break is totally optional. Let's compile this program. We'll see what we have. Now, what do we expect to have? Well, I is 1 coming into the program. So we should see this first statement, I is equal to 1. And let's add a little message here to remind us that this is the one-line if. And then down here, we're going to do the test for the different values of I in the specific if-else block. So we should see another statement that says I is equal to 1. In fact, I'll just go ahead and add a note up here that this is the if-else block. And then it's only 1, so it's not going to hit any of those other ones in that if-else block. And then we're doing another one here where it's a switch statement. And I should see I is equal to 1 case, because that's the case of I equals 1. It's the end of my program, so being a good programmer, I'm also going to add the return 0, because that's the end of the program. Let's go ahead and save and quit. And let's compile our program. I16 GCC. We're going to turn on all warnings. We're going to send the output to test.exe, and we're going to compile the file test.c. And we'll see if I made any errors. And I have one warning. The warning is I haven't used A, because I'll come back to that in a second. And that's OK. So if I run the program, we should see the output that we expect. There we go. We get all the output that we expect, that I is equal to 1 in each of our tests. And so that's how you do basic flow control, right? That's the important piece of branching out to different types of behavior depending on certain variables. Now, there's ways you can test multiple conditions at once. And let's go back into test.c. And I've got 2 variables. I is 1 and A is 2. So how do we combine our tests? I'll just add it down here. How do you combine the tests? I want to test if I is 1, and I want to test if A is 2. Now, that's not actually how I type it, because how do we tell the compiler we want to do an AND? I want to see if both of those values are true. Well, there's different types of comparators here, or combining your tests. There's going to be 2 ampersands is the same as saying and. 2 vertical bars is telling it to do an or. These are all logical. And if you ever need it, you can also use the exclamation point. That does a not. More information about that one in the guide, but let's explore the and the or. So let's first of all go ahead and change the and. Now, if wants to have stuff inside the parentheses, and here I've got if, and then inside the parentheses I've got I equals 1. It's going to get confused because it's going to see this and not quite know what to do. So let's actually make sure that the arguments to if, the tests for if, are inside their own parentheses. And remember, you can nest things using these parentheses. So here I've done a test that says I want to check if I is equal to 1, and I want to make sure that A is equal to 2. If both of those are true, then it's going to do what's inside this block here. And let's just put out the string that says I is 1 and A is 2. Oops, 2. And let's go ahead and add one more test so we can see what the or looks like. So if I is 0, which it's not, or A is 2, then we're going to do this block. So I've got an entirely different if statement here. And here we're going to say put S, I is 0, or A is 2. So when I run this with this program, I actually should see both of these lines get printed. I should see I is 0 or A is 1, because what's happening here? The compiler is going to say, oh, okay, is I equal to 0? Nope, I is 1. So that's false. Or, okay, well, now I can test the rest of this. Or A is equal to 2. Well, A is equal to 2, so it's going to execute this block. Just so that we know that it has a way to go if it doesn't actually work, let's do an else, and we'll do a put S. So, you know, I is not 1, and or right, A is not 2, right? Because if either one of those is the case, then it won't hit this block up here. It'll execute this part down here. And then down here we do the same thing. Else put S. I is not 0 and A is not 2. Okay. Mathematically, that's a contrapositive statement. But that'll only happen, I'll only see that message if I is not 0 and A is not 2. So we'll actually run this program a couple of times here just to see the different ways to run this. So let's go ahead and save our program. And we're going to recompile. This time we shouldn't get the warning about A not being used because we are now using A. And now we'll just run test. Okay, so we got a couple of other lines in there that I can probably comment out so we're not seeing the extra stuff. But we've done, so the second and third lines are the ones that I just added, right? So I is 1 and A is 2. And the next one, I is 0 or A is 2, because in this case, A is 2. Let's change some values here. Add test.c. Let's first of all just get rid of some lines so we don't have to see everything else all at once. I could comment this out. Actually, let's go ahead and comment this out, because just, oh, no, I got other comments in there. I don't want to nest my comments. All right, so let's go ahead and we'll delete this then. So we'll go ahead and delete those lines. All right, and now let's make I be equal to 0 and A is equal to 1. So in this case, what's going to happen? What do I expect is going to happen? It's going to do the test. Is I equal to 1? Nope, I is 0. So this will be false. And, okay, well, it won't get this far anyway, but A is also not equal to 2. Since it's an and, they both have to be true. And so it's not. So in this case, this will not run. So then it'll instead run the else. And so I should expect to see I is not 1 or A is not 2. Down here, it's going to do another test. If, and what's it testing? If I is 0, which is actually true, we've now set I to 0, or A is equal to 2, which is false because A is 1 now, that's going to be true. And the entire statement, rather, will be true. So that means we should see that. Just so we know what we're seeing, I expect to see this one printed. I is not 1, or A is not 2. I expect that one to be printed. And I expect this one to be printed. So I should see the greater than as sort of a flag that that's actually what's happening. So let's go ahead and save and recompile my program. And we'll run it. And we are getting exactly the lines that I expected to get. So that's ways that you can do testing with if and if-else and doing those switch statements. Now, there's other types of looping that you can do, or other types of flow control you can do. That's called looping. So how do you do looping? All right, let's do a quick program here called foobar. This is a classic C programming. Again, we're going to do include standard io.h, and the name of our function is int main, and there is the inside of our main function. Let's go ahead and set a variable. I is we'll set it as 1. Different types of loops. So before I actually get into the foobar example, let me actually show you about loops. There are different ways to do loops. One way that you can do a loop is with a while loop. And in the while loop, you want to do a test at the beginning. So while I is equal to 1, then I'm going to do this block. So what statements am I going to be doing? Well, let's go ahead and just say put s, and we'll just say this is a while loop so we know where it came from. I is 1. Oops. And by the way, at some point in that loop, you're going to want to change the value of I. So we're going to say I equals, we'll just add 1 to it. I equals 1. Another type of loop that you can do is a do loop. So a do loop, or actually it's more specifically a do while loop, is going to be do and then some block, and then while some condition is true, semicolon. By the way, up here, rather than saying while I is equal to 1, let's actually say while I is we'll just say less than 5, and then I'll change this text over here, less than 5. So while I is less than 5. Now, by the way, I will have gotten a new value up here, so we're going to set I equal to 1 again before we go into this. So inside this loop, again, we're going to print out put s, and in this case, it's coming from the do while loop. I is less than 5. And then we're going to do I equals I plus 1. I'm doing the same stuff inside the loop so you can kind of see what's happening. These are very similar loops, but there's an important difference. One is that with while, you're doing the evaluation before you go into loop. And then down here, with do while, you're saving that test at the end of every iteration of the loop. And so what's going to happen, let's actually, rather than a put s, let me change this one more time before we compile. Let's do a printf. And let's actually say I is, and let's actually say what it is. And then we'll just say it's less than 5. And so I now need to put in what I is. And let's do that the same down here. Rather than a put s, we'll actually do a printf. Do while I is some value. We're saying it's less than 5. And don't forget, we need new lines in there. Put s did not need new lines. Printf always does. Oops. And so we should see different loops here. Both of them starting with I equals 1, right? Because at the beginning of the program, we set I equals to 1. And then we're going to do this while loop. So what's that while loop going to look like? Well, as long as I is less than 5, do the loop. So is I less than 5? Evaluate before we enter the loop. Yep, I is 1. So all right, it's going to print out I is 1, which is less than 5. Then it's going to increment I by 1. It's going to add 1 to I. Now it's going to hit the end of the loop, and so say, okay, let's go back to the beginning of the loop. Is I still less than 5? Well, I is 2. So yes, it's going to print out I is 2, and it's going to add 1 to it, and now we're at the end of the loop, and so is I still less than 5? Yep, it's 2. It's going to do all of that until it gets to I equals 6. And then it's going to go back to the beginning and say, okay, is I, now that I is 6, is I less than 5? Nope, not less than 5. Actually, they're going to do, I take that back. It's going to stop when it hits 5. Because is 5 less than 5? No, 5 is equal to 5. So it's going to actually only print 1, 2, 3, and 4. Because once it hits 5, I equals 5, while I is less than 5, that's going to be a false statement, so it doesn't actually get to execute that part of the loop, and so it'll jump down here to the next one. The next statement is it sets I equal to 1. And now let's go ahead and start this other loop, the do while loop. So do, all right, no test at the beginning for that one, it's just going to do. And so it's going to print I equals 1. And then it's going to say add 1 to it. And then while I is less than 5, well now I is 2, which is still less than 5, so we're going to go ahead and do the loop over again. And so what happens when I equals 5? I will be 5, and then that'll be the end of the loop. And so we'll see here that we should get a 5 printed because it does the test after it increments I. Let's go ahead and, because I'm a good programmer, we'll do a return 0 at the end of my program. And let's save and quit. I16 GCC. We're going to turn on all warnings. We're going to do the output file into foobar.exe, and we're going to compile foobar.c. And no warnings on my program, so that's good. So let's go ahead and run foobar. So it has done I, 1, 2, 3, and 4. All of those are less than 5. Yep, all right, so why did it do that? So go back into the program. I is 1 at the beginning of the loop, and so it was able to print out I is 1. It increments it, and it goes to the next round of the loop. I is 2 at that point. It's still able to do the loop. I is 3, does the rest of the loop. I is 4, can still run that. I is rest of the loop. And now I is 5. So while I is less than 5, which it's not anymore, it's going to execute. It won't be able to execute that, and so now it exits to the end. Same thing down here. So it's going to enter the loop with do I equals 1, and then loop again if I is staying less than 5. I equals 2, print it again. 2 is still less than 5. I is 3. 3 is still less than 5, so it goes to the rest of the loop. Now it's 4. 4 is still less than 5, so it does the rest of the loop. And now I is 5. And so 5 is not less than 5, so it actually, I had it wrong before, it does not actually run the loop with I equals 5. But what's the important thing here is that there are some times it will be helpful to do the test at the beginning of a loop with while, and there are sometimes it's helpful to do the test at the end of the loop with do while. And so that's the way we can do 2 different types of tests. There's one other loop that you can do, and that's a for loop. So for you're going to use a lot, and so just like we did before with the while loop, you're going to have for, you're going to have some stuff in parentheses, and we're going to have a block of things we're going to execute for every time around that loop. So what goes inside the parentheses? Well, you don't actually need to set the value of I before the loop like we did with the do while or the while. You actually put that in here at the beginning. So I is equal to 1. That happens before you enter the loop, before the loop even starts up. And then you put in the test that says, all right, let's actually test this to see if it's going to still be true. And then I is less than 5. I'm separating these with semicolons, but this is the test to see if the loop should run again. And then what do I do at the end of every loop? Well, at the end of my do while, I had I equals I plus 1, and I had I equals I plus 1. So you do the same thing. I equals I plus 1. And then inside that loop, we want to do a printf statement, and this is the for loop. Oops. The for loop, I is, we'll give it a value, and that's less than 5. Okay? And I don't need to add the extra I equals I plus 1 because that is already part of my for statement. So it's a simpler way to write a loop. Let's go ahead and compile this program. GCC, turning on all warnings. Output is foobar.exe. We're compiling foobar.c. Oops. When you do the for loop, you don't put in the last semicolon. You want to separate your values with semicolons, but you don't have a semicolon at the end. So that was my error. Go ahead and save and quit. We'll recompile. And now we run foobar. And so we get the same output on all of them because they're all doing basically the same type of loop. And for is just a tighter way to run a loop. So what can we do with loops? You can do lots of great stuff with loops. So we can do a loop in foobar. A typical thing that you might do. This happens a lot in interview questions for some reason. But here we'll just do the int, and in this case we'll just say it's an iteration variable, so we'll call it iter. I want to do a program here. Let's do a comment that says loop through iter from 1 to 20, and then for any iter equally divisible by 3, print foo. For any iter equally divisible by 5, print bar. But at the same time, print iter. So that means we're going to get the numbers 1 through 20. And we're going to print out the number 1. We're going to print out the number 2. We're going to print out 3 followed by foo. We're going to print out 4. We're going to print out 5 followed by bar. We're going to print out 6 followed by foo and bar, and so on, right? So you can see if it's divisible by, I'm sorry, the last one was divisible by 6, so it's divisible by 3, so it's really just foo, not foo bar. So at 15, for example, we'll get foo bar. So how do we do that? That is going to be with a loop, and so to do that, we need to do a for loop. All right, so we're going to do for, and then we're going to start the iteration value at 1. We want to do iteration needs to be not less than 20, but less than and equal to 20, right? And we need to make sure we include the endpoints, 20. And then I equals I plus 1. And then inside that loop, we're going to do our tests. So now we're going to combine looping with different types of tests. Let's first of all print out, using a printf, the number, and we'll put in a space after it. Now I don't want to put in a new line yet, so we're just going to do the number and then a space, and that's iter. Now let's do our tests. So if, and how do I detect if something is divisible by 3? Well, do you remember the modulo operator? If iter modulo 3, and if it's, this is the remainder, so it's the iter divided by 3, but it's the remainder after that. And so if it's equally divisible by 3, that modulo should be 0. So I want to test if iter modulo 3 is equal to 0, then I'm going to do some stuff. What am I going to do? Well, I'm going to print out. Oh, yep, I'm going to do printf foo. I also want to test iter modulo 5 is equal to 0, right? If it's equally divisible by 5, then do some stuff. And what am I doing? I'm going to printf bar. And then when I'm done, whether or not those if statements actually printed anything out, I still printed out my number, and I need to make a new line. And so let's go ahead and do a new line. And then it's going to reach the end of my loop, and the loop will start over again. And so that's a simple way that you can run a loop. Let's go ahead and save and quit. And we're going to do compile our program. And it looks like I made an error. What did I do? Oops. I did iter. I did I instead of iter. So I need to do. Let's go ahead and fix that. Alrighty. Over here was iter. Save and quit, and recompile. Always compile with warnings on, and then you want to try and write warning-free code. And so now if I do foobar, I should see the numbers 1 through 20. The ones that are divisible by 3 will have foo next to them. The ones that are divisible by 5 will have bar next to them. And the ones that are divisible by both 3 and 5 will have foobar written next to them. And there you are. So what's the one that's got foobar written next to it is 15, right? So the ones with foo next to them are 3, 6, 9, 12, 15, and 18. And if I go on to 21, 21 would have one as well because that's divisible by 3. And then the ones divisible by 5, 5, 10, 15, and 20. They have the word bar after them. And then 15 has foo bar after it. Right? So this is a typical way to kind of run these different types of tests. Now, we can write the version of the FreeDOS pause command. We can actually start writing our own version of the FreeDOS pause command. So let's go ahead and we'll write our own version. Let's call this one pause. I don't want to have a name conflict with the internal pause command, so we'll just call this one pause. And so don't forget we need our include standard io.h int main. So what do we want to do? What does the pause command do? Well, let's remind ourselves real quick here what the pause command does. So if I do pause, it's just going to say, all right, press any key to continue. And there we go. That's all it does. It just literally pauses a batch file, usually so you can see the output of a program. So let's go ahead and write a version of this. But instead of hitting any key, in this case, we're going to actually look for the return key. So how do we do that? So we are going to need to read characters from the keyboard. And in that case, we need to do, we're going to have a character variable, and we'll just call it ch. Now, what's my prompt? We're going to do a put s, press enter to continue. And now I want to loop until we find a new line. What's the new line? New line is \n. So we want to do a do loop that will execute while the ch is not equal to, new line. Now, characters, by the way, you don't put inside the double quotes. That would be a string because it's got these double quotes around it. To make it into a character value, character values have single quotes around them. And so I want to test, do this loop as long as ch is not equal to n. And what are we doing inside here? Well, we're doing ch. We need to somehow get that character from the user, from the keyboard. And the function to do that is getChar. And that'll read a single character from the user. And it's now going to execute that loop where it's going to continually get another character from the user as long as that character is not a new line. And then when it's done, we'll go ahead and just print something out to the user saying, okay, we're done because we reached the end, and I'm a good programmer, so I'm going to always return 0 back to the environment. So this is all you need to write your own version of the pause command. In this case, we're hitting enter instead of any key, but it's the same concept. Let's go ahead and save and quit. I16 GCC, we'll turn on all warnings. We'll do the output going into onepause.exe, and we're going to compile pause.c. And I have done something wrong. What did I do wrong? Oh, I don't actually have a pause.c. I forgot it was called onepause.c. That was my error. There we go. And now we do one pause and press enter to continue. Well, I could press anything in here, right? H, different characters on the keyboard. And it's not until I hit enter that it actually exits. Now, let me actually show you real quick what it's actually doing every time we do the loop. How do we actually know that it's actually not just, how do we know it's actually reading the character every time and not doing something else? Well, I can actually do that here. Let's do fed onepause.c. This will be our last example. So we're going to do a debugging statement in here. It's always good in your programs. You might need to have a debugging statement just to check that your program is doing the thing you expect it to do. And in this case, we're going to do a printf that just says, well, we'll tell it it's a debugging statement. And then we're going to put the character to the screen. It's a %C. And then don't forget, we need to have a new line if we're going to be putting that in there. And then there's ch, the character we're going to print out. Just so we can see specifically what's in there, I'm going to go ahead and close this in parentheses. You can actually see what character we've read. And then save and quit. And now let's recompile our program. And here we are. We're going to go ahead and run one pause. So if I just hit enter right away, debugging says it read that. Well, what did it read? This is why I put it inside the parentheses. It read an actual new line. That's why literally what you're seeing here is paren, open parenthesis, from the debugging line, and then a new line. It actually goes to the next line, and that's why it wraps around like that, and then the close parenthesis, right? So that's why you've got those parentheses on different lines. If I ran that again, and in this case, I actually just put in some letters, A, S, E, F, and then I hit return. It actually is processing all those, but it's actually not going to process them until I actually hit return. So it's looking for, it's processing A. That's not equal to new line, so it's going to do it again, and read S, and then it did it again, and read D, did it again until it did F, and did it again until it got new line, and then it said, okay, I can exit my loop now. So that is an example on how you test and do different loops in C. Now, this video is already 52 minutes long, so I'm going to pause here, and we'll cover functions in a different unit of the video series. But also look to the programming guide for some other examples on loops and if statements and these conditional branching. Before I go, I just want to thank the patrons out there. You really do make this channel happen. I definitely appreciate everyone's support. Some of you have contributed at a higher level, and so I wanted to recognize you here. Thank you very, very much. And that's it for this video. So I hope you're enjoying the video series. Leave comments below. Also, visit our website at freedos.org. Join us on Facebook, follow us on Twitter, and consider supporting me on Patreon. Thank you.